For those of you listening at home, hi John, and Michael, good to see you. By the way, click subscribe and click like. Maybe you did. It's on YouTube. So I never knew what that would actually do except for stroking my own ego.
It makes it so that you you can
Like,
so I get notified when you post a video.
Oh, that's right.
That
That's true.
That way you don't get lost
That's
in
true.
the internet.
Right. And I don't have any microtransactions or anything, so I don't get any money. So the third would be input changes. For example, the sine of 3 theta is equal to 1/2. When they actually start missing with the input, it's called an input change. And then the fourth would be a multi-step with factoring. And I'll show you what that means in a moment. The ones are, well, just as an example. 4 sine squared of theta minus 1 equals 0. So, what we're going to focus on today, we've mainly done this so far, the basic ones. That was 1 through 10 on the worksheet you've done so far. So hopefully those are getting a little more comfy. If you know the positions on the unit circle for common angles, this is not as stressful. And you can do it pretty quickly, at least in theory. This second part is what we're going to focus on mainly today, because that's the second half of the worksheet I gave you. So we're going to start slogging through some of these problems. For example, let's try that one. 2 sine of theta plus 1 is equal to 3. Now the question is, what are we supposed to do with this? It looks vaguely like an algebra problem, but it's got trig embedded in it, which is awkward. The cure for this is, normally in algebra you're supposed to get x by itself when you solve. What I want to do is it's a little different. Get sine of theta by itself. I'm not trying to get theta by itself, not yet. I'm trying to get sine of theta by itself. Let's see if we can actually do that. Just pretend it's a big algebra problem. Don't try and treat this as one big lump. 2 times lump plus 1 equals 3. Can you get the lump by itself? Sophie, what would you do? Definitely. From both sides. What do you get so far? 2 sine of theta equals 2. What would you do next? Yeah, divide by 2 on both sides. What do you get? Congratulations, you are done with part 1. The worksheet is probably going to say solve for theta. Does anyone remember what this means? Can we translate this into English for me? What does square bracket mean? Yeah. Included. How about round? Not including. So basically any number from 0 to 360 degrees. In other words, once around the circle, and then stopping just short of 360, because it's the same spot as 0. We just don't want to count it twice. So question. Oh, unit circle remembering people. Where is sine of theta equal to 1? Does it ever? Should I say Sean? 90 degrees. What is sine on the unit circle? Height. Sine is height. How far up down? And this is a unit circle, so what's the radius? It's 1. The only place on the unit circle that's 1 space up is right here. So theta equals what? Nice. Now, somebody do me a favor. What's that in radians? Feet. What's 90 degrees in radians? How do you get that?
Well, 360 is 2 pi radians, you just kind of like divide by 2, divide by 2.
Exactly. 360 degrees is 2 pi. Probably an even easier one to memorize is 180 degrees is 1 pi. Then you can multiply up or down from there. 360 works perfectly well. So yeah, so you get pi over 2. If I ask you, by the way, how would you tell, if I say this, then you should put this as a solution. That equals 90 degrees. What if I did this? Solve for, can somebody translate this? Joey Miller, what's this mean?
Like in words?
Yeah.
Theta yields 0,
Well, not yields, but
belongs
belong to.
0, 2 pi, including.
So basically anything from what to what?
0 to right.
0 to 2 pi, including 0?
Yes.
Including 2 pi? Good, not including 2 pi. So in this case, you would put theta equals pi over 2. There will be something in the instructions on the test that will give away whether I want degrees or radians. What symbol do we use for radians? Semi-trick question. We use this little circle thingy for degrees. What do we use for radians?
I don't remember.
I'm actually glad you don't.
I thought there wasn't one.
Correct. There isn't one. There is no symbol for radians whatsoever. Which means, for those of you who might be disposed to forget your degree signs on degree answers, we have a problem. Guess what I'm going to assume that is? 90 radians, which is enormous. The radian's about 57 degrees. Look at from there. 57 times 90 is big. So it's something bigger than 90 degrees. Questions? So that's what I mean with output changes. If you can do that, I'm going to do another one in a moment. But that's basically what the second half of the worksheet is all about. Doing this and getting sine by itself, or getting cosine by itself, or getting tangent by itself. Okay, ready. Does anybody have this over here? The list? Okay. Let me try another one. As a matter of fact, I think I have a really exciting one for you. Yeah, why not? No, that's, I think you're going to forgive me. I had a really good, here it is. I want to solve for, and I'll do degrees this time. And again, this from 0 to 360 just means all the possible solutions one trip around the circle. So, Jack Lau, what did you start with?
You can, we could multiply 2 to both sides.
You good? That's perfectly legit. There's two ways to do this. That is a legit way to do it. Want to do it?
Yeah.
Okay.
Yeah.
So,
Unless you want us to do the other one.
my emotions are not part of this. So, what, not yet. So you want to multiply both sides? Like
Yeah.
Okay.
2's cancel.
Okay.
We got 10 plus 2 sine of theta
10 plus 2 sine of theta.
equals 10 plus radical 3.
Okay.
You
Now
can
what?
subtract 10 from both sides.
Yeah, subtract 10 from both sides. By the way, what happens?
They both cancel.
They both cancel.
We
That's
got
called
2
lucky.
sine of theta
2 sine of theta.
equals positive radical 3.
Okay.
You can divide by 2 from both sides.
Good. You notice we're trying to get sine of theta by itself? Okay.
And you got sine of theta is radical 3 over 2, which means that theta is 60 degrees and 120 degrees.
Okay, I'll back up. By the way, you're right. Whenever you get to sine of theta or cosine of theta or tangent of theta equals something, one thing you have to ask yourself, is this a common angle or an uncommon angle? So Jack, common or uncommon? How do you know?
This radical 3/2 is like the basic sign of some of the common angles.
Right, multiples of 30, 45, or 90. I know, 30, multiples of 30. What gave that away?
The radical 3 that are the 30, 60, 90 degree.
Right, this comes from a 30, 60, 90 degree triangle. So there, basically, if it's a common angle, it's a multiple of 30, or a multiple of 45, or a multiple of 90. And if you have something that has a 2 and a radical 3, you say, wait a minute, I've seen that in the 30, 60, 90 triangle. It's got to be a multiple of 30. 30, 60, and 90 are all multiples of 30. So, actually, Jack, finish this off for me again. Sorry, where was it? First of all, is sine up, down, left, right, or slope?
Signs are down.
Up, down. Is that up or down?
It's up, it's positive, so it's
Up a lot or a little?
a lot.
A lot. What would the little be
1/2.
if it were 1/2? So where are we again? You said
60 and 120. 60 degrees.
6 degrees?
20 degrees.
Correct. And so what you put as your solutions, theta equals 60 degrees, theta equals 120 degrees. Can somebody convert those to radians for me? Julie, what's 60 degrees in radians? First of all, what's 180 degrees? Or you do 360 if you want. 180 degrees is how many radians? Yeah, Julie? Pi. So if you want to write this down in your notes, if you don't have it, 180 degrees is equal to pi, I'm going to put in parentheses, radians. You can use that to find any other ones. How do you go down to 60? Actually, Jen, no, try this one. How do you just, what do you divide by to get to 60? Just have to do it too. What do you get? Alright. What's 120? Little thing except anybody. 120 degrees what in radians. I'll give you a hint. It's actually easier to go from 60. Steve, what do you think?
Should be 2 pi over 3.
2 pi over 3. It's 2 of these. Right. Let's try another one. I'm going to step up the, give me 30 seconds here, I got a snazzy problem here. Yes, so we've got. Perfect. Try this. All math smarty pantses. I want you to solve, and I'll stick to degrees just for now. Just as a hint, in case you don't remember from last year, cosine squared of theta is a fancy way of writing this. Cosine of theta squared. The reason they do this is because if you write this, do you see what people might assume?
That's just the theta.
That's just a theta that's squared, yeah. This removes all confusion. So if you put the squared on the cosine, that means the whole cosine is squared. That's this thing. So, brainstorm. I deliberately put a problem on the board that probably nobody in here has ever seen before. And it is. Yeah. You might be able to factor this. How? There are 7 basic methods of factoring.
All that substitution.
Ah, interesting. By the way, can somebody name me the 7 basic methods of factoring? What's the very first? Always. You can go into this one too. GCF. GCF on foil. Binomial squared, that's actually the next one. Magic pair, substitution, difference two squares,
Foil.
and if there's four terms,
Oh,
Yeah.
yeah.
grouping. All right. Now then, which method, there are actually two methods you could use here that could work. Suggestions? What do you think? If I just gave this to you in, I mean, heaven forbid, I give this, believe it or not, I think I put this on in class number 66. This is a factoring problem here. Number 65, my fault. No, it is 66. How do you do something like this? It looks like a monster. Yeah.
Well, the substitution is to replace the cosine, it's just like a variable.
A variable. Pick your favorite variable.
X.
Sure. So x equals what? What would you substitute?
Cosine right there.
Yeah, the thing that looks horrible. Look at the thing that looks horrible and rename it something nice. Can somebody rewrite this in terms of that new spanking variable?
2x squared
Huh?
minus 3x
Yes.
plus 1 equals 0.
Exactly. That should be a little more comfy. Does anybody see what method you use now? What method of factoring? There's a 2 in front. That's a good giveaway. Yeah. Okay. I'm going to do the opposite, by the way. First of all, is there a GCF? No, other than 1, which is boring. Can we unfoil? Why not? What's stopping us? Go. There's a 2 in front. There has to be plain old x squared from unfoil. Unfoil is where you add to make this and multiply to be this. Right? Yeah. Let's try it. Binomial squared has a 3-step pattern. Remember? Yeah. Square the first, double the product, square the last. Does this seem to match that or no? Is this something squared? Half of it is. Half of it. If this were 4x squared, I'd say, yeah, it's a possibility. The 2 is not a squared. So it's so close, but yeah, the 1 was nice. The 2, so I would have liked it. So it looks like binomial squared didn't work. Is this a difference of 2 squares? Julia Sushant. Why not? Yeah, you have 3 terms. It's supposed to be a square minus a square for difference of 2 squares. Can we factor by grouping? Gee. Why not? There are only 3 terms, and you need how many? 4, or an even number. What are we resorting to here? Magic pair. Tell me how to do that.
Multiply the first 2 terms.
Multiply the first and the
Last.
first and the last. Go ahead and do that.
So you have 2x squared.
2x squared, and now what?
And then you list the multiples, and they should add up to negative 3.
Right. List all the factor pairs. There aren't very many. What are they?
So 1, 2,
1x and 2x, and I think only one other.
and then negative,
Negative 1x and
negative 2.
negative 2x. I don't know of any other ones without decimals or fractions or anything like that. Do either of those pairs work? To the decision.
Negative 2x.
Why does that work?
Because they're negative.
Okay, and they add up to
They have to be negative.
negative 3x. Put an addition sign here. What do you do with this? This is called the magic pair. MP, not to be confused with military police. And go.
You put it in place of negative 3x.
Go for it. Tell me what I get.
2x plus negative.
Good.
Oh, squared,
Squared.
sorry. Negative 1x
Uh-huh.
plus negative 2x
Uh,
plus 1.
Yes.
So,
And now what?
then you group
Grouping. What little miniature GCF comes out of here?
2x.
I should just,
Oh, negative 2x.
this doesn't have a 2 in it.
Sorry, negative x.
You're very close. The only time I pull out a negative is if the very first term is negative.
Oh,
If it's starting.
x.
Just x. What's left behind?
2x plus negative 1.
Good. Now this one,
Negative x.
it would, but this is no x. Negative something.
1.
Just plain old negative 1. What's left behind?
2x plus negative 1.
Good. Take over, you want to try? Is this gonna work?
Yeah.
Yeah. What do you do with this?
You put them into one,
Yeah, pull in front. What do you get?
2x minus 1,
Okay. And then what's the leftovers?
x minus 1.
Equals 0. Can somebody solve this for me? Jack Lau.
2x minus 1 equals 0. So, or add 1 to both sides.
Hold on a second. And then,
X minus 1 equals 0.
what did you just do? What's the name of that? Something times something is 0.
Yeah.
What's the answer to a multiplication problem?
Product.
Is it 0 product?
Is the zero product property. Bravo. Go ahead, Jack. Go.
Add 1 to both sides.
Jack?
2x equals 1. Divide by 2. You got x equals 1 half.
X equals 1/2. Good.
1 to both sides. X equals 1.
Okay, we can't write that fast. X equals 1. Now, are we done? Pete. Look at the original problem. We got, ta-da. Something looks very different.
Well, you only have two x's, right?
I have two x's. I've got x equals 1/2 and x equals 1. That's correct. We've done it all right so far. Just want to know if we're done. No. What's wrong? Sophie. Yeah, you remember? The whole thing started with cosines. We've got to put that, in substitution. It's kind of like the rule we had in kindergarten. When you're done playing with something, put it back where you found it. So we've been playing with the x for a while. So instead of x equals 1/2 and x equals 1, what should it be? No.
Cosine of theta equals 1/2.
Cosine of theta equals 1/2 and
What?
cosine of theta equals 1. I will warn you, sometimes you can get more than two solutions this way. You might get 3, you might get 4. So, we can take an attack, please. Go.
The first one is 60 degrees or 140 degrees.
Cosine, we'll double check. Cosine is left, right, up, down, or slope.
Actually, not what 120. 300.
Cosine, positive, a little. So it's going to be a multiple of 30 up here. And where's up again? In degrees.
60 degrees.
60, and where's this?
300.
300, correct. Now that's great. You've got two solutions. Bravo. We've got to do this one as well. Take this one. Is cosine of theta ever equal to 1? What is cosine? Is it left, right, up, down, or slope? Left, right. Is it ever? Yeah, at 0 and 360. Which one are they allowing us to use? 0. Theta equals 0 degrees. So what are how many solutions do you have?
2. Sorry, 3.
3. Name them.
Theta equals 60 degrees, theta equals 300 degrees, and theta equals 0 degrees.
Correct. And that is your final answer. Does that make sense? That is not on your worksheet that you're doing tonight. It'll be for stuff next week. Questions? You know, Candace? All right. The rest of the hour is yours. You may work in groups quietly or on your own if you wish. Have this done by Monday. Enjoy. Or good luck. Or both. And for those listening at home, cheerio. The worksheet 11 through 20, well, basically 1 through 20 for Monday. God bless you all. Hope you feel better soon. Bye.